Okay, so um, I'm kind of wanting to demonstrate battery balancing and why I've chose to um, do a battery balancing circuit or a battery management system in the EV. The reason I'm doing that is, and I can't find my tripod, so I'll have to fill and then shoot, fill it with water and then show you guys. But this right here, I don't know if you can see my little marks right there. We got 2.5, 3, and 4.2 on each one of these. And as you can see, like if I was to do this, since I'm using a wide variety of batteries that have been harvested from recycled laptop batteries and other sources, each battery, even in if you bought them all from the same source, same manufacturer, each one's going to have a little bit different battery chemistry, not chemistry, but it's going to charge faster, it's going to discharge, charge at different rates and discharge at different rates, and the internal resistances are going to be different, and especially when you start getting into recycled batteries or batteries that you've harvested from other sources, there's really going to be no way to, even if you're grouping them together by a certain performance matrix, each one's going to have such a different rate that you can really start overcharging or discharging a battery past its limits, and then you start really losing performance. So I've chose to go to a battery charging circuit or a battery management system circuit that I'm putting together because of this. So I'm going to go ahead and fill this with a little bit of water and kind of demonstrate how this, more of a visual demonstration of how different batteries might fill. So the liquid obviously is representing your charge and discharge, and each battery is going to charge and discharge at a different rate here. So let me go ahead and fill that and I'll be right back. Okay, so as you can see here, I've got this sort of filled with some water here, and this one's charging really fast. This one, not so much, and this one's not even charging at all. And so, this is kind of a very simplified version, but I'm going to go ahead and put some more water in here. And obviously, certain batteries are going to do a lot different here. And so part of what I wanted to show is you can see here the battery on the left here is already charged. And then the battery here in the middle is slowly charging. Now this one, as you can see here, has overcharged. And then the one over there, I kind of wanted it to do a little bit of charging, but I guess this just kind of shows you that now this pack, in series, is putting out, we got almost 5 volts here, maybe 3.2 here, and 2.5. So let's make this easy. 5 volts, 3 volts, and 2.5. So 5, 6, 7, 8, 9, 10.5. So this pack would put out 10.5 volts. Now, how would you know if you didn't have a battery monitoring system? Which cell, 10.5 volts, so you're going to assume that, you've got an even distribution here, when in fact you don't. And this one's going to discharge, they could discharge at different rates. This might discharge extremely fast and lose its charge, or this one might, there's really no telling how these are acting without some sort of monitoring. So that's why I've decided to do a battery monitoring system, because I want to be able to determine the performance of each cell and optimize my pack. So it's what a battery balancing circuit is going to do. There's a lot of stuff inside the management circuit, but it's going to say, okay, this one is charged, so let's apply current to this one and this one to get them charged. And then as this one got to the limit that you set, it would make sure that only this one's getting charged. That way they're all fully charged or at the voltage limit that you want. And then as they discharge, if this one's discharging really fast, it's going to stop discharging this one and let these two catch up. And that way you're always getting the peak performance out of your batteries. And I think this is really important when you get into batteries that are, there's really no telling what stage of life they're at, how well they're performing with harvested batteries. So it's even more important at that stage. And so that's why I'm paying more. I'm paying less for the batteries, but I'm paying more when you add in the circuit. And I'm still going to come out less than what it would cost to buy packs already assembled. But I'm going to be way more than if I had just bought the batteries and wasn't too concerned about the battery monitoring. But hopefully I didn't ramble on too much, and this helps people understand the importance of a battery management system, and especially when you're using a wide variety of batteries, at different stages of their life and different efficiencies. If they're the same if they're the same batteries from the same manufacturer, you're still going to have slight variances, and a battery management system is definitely going to help you get the best performance. The one that I'm putting together, the circuitry talks about being able to increase your performance up to 92%. And I don't know the statistics of a pack that's not managed. And I think I'll actually maybe put together a pack that's managed and a pack that's not managed, just to kind of see what I can do to display or to showcase efficiency differences. But again, hopefully I didn't ramble on too much, and sorry for just showing this. But I think that this is a pretty simplistic way of showing how batteries can charge. Because up here, as your rail that connects all the batteries, it's going to, based on the internal resistance of the batteries, it's going to feed to whatever is the least resistance, and it's going to only give the battery what it's willing to take. And if it's willing to take more over here and less over here, that's what it's going to do. And if you overcharge this battery and undercharge this one, but you're still getting the voltage that you thought you would, you're really going to destroy this battery real quick, or destroy this battery real quick. But okay, enough rambling. Thanks for watching. Subscribe if you want to hear more about this project, and like and share with other people that might be interested. I appreciate it. Thanks. Bye.